Okay, so I should tell you, you might say, why isn't she capitalizing L in the title for logarithms? My new computer has a problem when I have type an uppercase L, it locks everything up. So I gotta do some research on that. But anyway, that's why. Okay, so properties of common logarithms. So remember we had the property, this is a good time to review. We had the property log base b of 1, and we said, oh, that just equals 0. So what it means is if I have a common log of 1, well, that's going to equal 0. The base was just 10, and that's not going to make any difference on that one. Okay. And then remember we said, well, if you have log base b of b, so if the argument and the base are the same, that just equals 1. So for common logs, if I have log of 10, so there's no base that's written, but we understand it's 10, like that's the secret. Log just means log base 10. Okay, so the base and the argument are the same, so that's just going to equal 1. All right, and our property 3 says if you have log base b to the x, that just equals x. So for a common log, it would look like log, and then if you have 10 to some exponent, that's going to just equal x. And then 4, if you have b to the log base b of x, that just equals x. So in the world of common logs, it would be 10, and then up here you'd have log x, but you wouldn't have a subscript there because it's understood, and then that would just equal x. So those are all the properties if we had a base 10, so the common logarithms, okay? So probably not too earth-shattering. Okay, speaking of that, we're going to talk about earthquakes. So earthquakes are on a logarithmic scale. So the magnitude R on the Richter scale, that's how we measure earthquakes. So the magnitude R on the Richter scale of an earthquake of intensity I. So we'll talk about this a little bit. So how strong, how intense is that earthquake? And it's given by, and then here's the formula. Okay, so R equals log, it's a common log, I divided by I naught. Okay, now I naught, or the initial intensity, that is the intensity of a barely felt zero level earthquake. So the earth is always moving. We just don't always feel it unless there's an earthquake, right? Okay, so we're on the earth and it's moving a little bit, but we can't really feel it. So it's just a little bit, and that's a zero level earthquake, okay? But then when an earthquake hits, then, on the Richter scale, you've seen those things on TV where it's really jumping, the needle's really jumping. But it's always moving a little bit. Okay. The earthquake that destroyed San Francisco in 1906 was 10.83 times as intense as a zero level earthquake. Okay, a zero level earthquake is I naught. So the San Francisco one, I'll just put San Fran, that was 10 to the 8.3 times I naught. Okay, that's how strong the earthquake was in 1906 in San Francisco. Okay, so what was its magnitude on the Richter scale? So here we're going to use then this formula. R equals log, common log, and if you want, you can put parentheses, I over I naught. Well, what was the intensity of the San Francisco earthquake? Right there. So on the Richter scale, then that's going to be log. And then here we go. It's 10 to the 8.3 I naught over I naught. Okay? So the intensity of the San Francisco earthquake, which we have right here, it's 10 to the 8.3 times as intense as a zero level earthquake. Okay, and then we're dividing by a zero level earthquake. Okay, well, what happens? Those I naughts cancel. So now I have R equals common log, and this is 10 to the 8.3. Now I like the parentheses, but I'm not going to put them, but I like them. All right, that is property 3. Property 3. Property 3 says if you have a log, base b to the x, and those are the same. In a common log, it's when you have 10 to some exponent just equals x. So then this is the Richter scale number then is going to be 8.3. So that was what it measured on the Richter scale in San Francisco in 1906. It was an 8.3 earthquake.